Okay, part 2. So, what we're going to do instead of going by the graph, because the graph is going to be a little too funky, I'll show you what I mean in a minute. This is just saying let x equal 0, and this is saying let x equal 2 pi. Figure out the coordinate point for these 2 points, and then figure out the slope between these 2 points. So if we let x equal 0, plug it in there to the original, we can figure out what y is. It's going to take a little bit. So if we say, okay, let's let x equal 0, we're going to get negative sine 0, because that's our x, plus, I'm just going to write in 45 degrees. I could have typed in pi over 4, but plus 2. The reason I typed in 45 instead of pi over 4 is my calculator, I believe, is in degree mode. So I'm going to stick with degrees. And so now I'm going to figure out what sine of 45 degrees is. So sine of 45. But there's a negative there, so it's negative 0.707 plus 2. So I'm going to put plus 2, and I get 2.707. So my first point is 0, 2.707. Now I'm going to plug in this. Well, what is that? That's 360. So now I'm going to type in y equals negative sine. My x value is negative 360. So that's, it's 360. So 360 plus 45 plus 2. That's actually 405. So I'm going to type sine of 405. And notice I get negative 0.707 again, plus 2 again. And so, oh, I screwed this up. It's not, boy, oh boy. Okay, good thing I caught that little mistakes there. So, 2 minus 0.707 is the same thing here. So I'm going to write that in 2 minus 0.707. So I get 1.293. That's what this should have been. Wonder if you guys caught that. Then I get the same thing here, 293. So notice, my first point is this. My second point is 360, 1.293. Now notice my y's are the same. So if I use this formula for the rate of change, I'm going to get, this is my x1, y1. I'm running out of space here, x2, y2. So if I go y2 minus y1, anything minus itself is 0. So I get 0 in the top. In the bottom, I get 360, x sub 2 minus x sub 1. But it doesn't matter what this is. 0 over anything is 0. So there's my answer right there. That took a lot of work, but we got it. All right. Okay, number 10. It's got a little trickeration to it. But it says, what is the equation of the midline? So, essentially, if cosine looks like this, we're looking for the line that cuts it right in half. So, we know right away it's going to be y equals some number because all horizontal lines are y equals some number. Now, here's the little tricky part in this. We're going to start by just thinking about the parent function, y equals cosine of x, and make some adjustments. So, let me pause this and get some tick marks on. Okay, so just to get started with cosine, remember it goes over the origin, and then it's going to be like this, and then it kind of goes like this, and then back. And then this is going to go through here, 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 and like that. Okay, not perfect, but this is actually supposed to be, thought I messed that up a little bit, down here, and then here, and then up there like that. There, that looks much better. So the point I'm trying to make is, if this was the end of our graph, our answer would be y equals 0, because it cuts it right in half. But then here comes the adjustments. The amplitude is doubled. So we know, and I'm going to make this dotted, so that is up 1, so that goes up to 2. These don't change, but that, if it's down -1, it goes down to -2. That doesn't change. Up 1 goes to up 2. those zeros don't change. -1 goes to -2. 0 doesn't change. 1 goes to 2. So I change the drawing like so. And I ask myself, how did that change the midline? Well, it wouldn't, because this still cuts it right in half. This is 2 above the x-axis. This is 2 below the x-axis. So if this is where it ended, my answer would still be y equals 0 for the midline. Now, this right here would change the period. And that means it would either stretch it out like this, or it would vertically, or it would go like this and scrunch it a whole bunch, so you get a whole bunch more intervals in the same amount of time. Here's the point I'm trying to make. The vertical, the horizontal shrink or the horizontal stretch is not going to move the midline either. So although this is challenging, it's not going to change the midline. It just scrunches it together or it stretches it out. But as you can see, the midline is not going to change. So we're going to focus on this because this is going to be your game changer. It's going to take that orange graph and it's going to drop it down 3 units. So I got to be really careful here with these extreme points, these anchor points. So that's up 2. If I move that down 3, it's going to end up down 1. This is at 0. That would end up at down 3. This right here is down 2. If I drop that down 3, that'd be down 5. This 0 drops down to -3. So as you can see, it's starting to go like this. This 2, if it drops down 3, it's going to end up here. This drops down to -3. This drops down to -5. You can see where this graph is going. And then that right there would drop down to -1. So there it is. There's my final graph of this. Now I did not worry about this at all because it's not going to change the midline. Well, if this is down -1 and this is down -5, there are 4 units in between here. So if I go down 2 from there or up 2 from here, that's going to be the midline right there. So what's its name? Y equals -3. So that problem took a while. Okay, number 11. From a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia. So there's the plaza. And there's my 340 feet away. So this is our position right here. It says the angle of elevation, which is right here from your perspective, to the top of the building is 65 degrees. Find the height, which I've labeled as X. Well, if this is my reference angle, that makes this the opposite. And this has to be my adjacent side because we know that this has to be the hypotenuse. So what trig function involves this and this? Well, if we look at SOHCAHTOA, opposite, adjacent, is used by tangent. That tells us we have to use tangent of 65 degrees is opposite over adjacent. We got to look this up with our calculator. Make sure you're in degree mode. So now we're going to go tangent of 65. So we get 2.14 equals X over 340. But we got to multiply by 340, both sides. And then here comes our answer. Times 340. 729.13. There you go. There's the height of the building. All right. So number 12.